Okay. Okay, so still on basic engineering hydrology, we are going to be looking at hydrographs. Okay, so we have a problem here on unit hydrograph. So the question says, given below are observed flows from a storm of 6 hours duration on a stream with catchment area of 500 kilometers square, assuming the base flow to be 20 meter cubes per second, derive the ordinate of the 6-hour unit hydrograph. Okay, so from this problem, we are given the time and we are given our 6-hour hydrograph. So we were asked to calculate the ordinates of the unit hydrograph. Okay, so what else are we given? We are given our area to be 500 kilometers square, which is 500 times 1,000 meters square, and that will give us what? 5 times 10 raised to power 8 meter square. Okay, so and we are giving our base flow to be meter cube per second. So what's the first thing that we do? So the first thing that we have to do is to get our 6-hour direct runoff hydrograph. Okay, so our direct runoff hydrograph is simply equal to our hydrograph minus base flow. Okay, so that's the first thing we get. So computing for our 6-hour direct runoff hydrograph is simply the values in the hydrograph table minus the base flow. So for this, we have what? 20 minus 20, which our base flow given was 20. So we have this to be what? 0. Okay, so to get our 6-hour hydrograph, we simply have that to get our 6-hour direct runoff hydrograph, we simply have that that is equal to our hydrograph minus base flow. Okay, so to get the direct runoff hydrograph for this point, for this time, is simply 20 minus the base flow, which is 20. So we have 0. So for the next, we have 120 minus 20, we have 100. So we have 270 minus 20, 250. Okay, so we have gotten the values of our 6-hour direction of hydrograph, which is simply removing the base flow from each of the values of the 6-hour hydrograph. So what's the next thing to do? The question says we should get our ordinate of unit hydrograph. So the next thing to get is the ordinate of our unit hydrograph. Okay, so our ordinate of unit hydrograph, so ordinate of unit hydrograph is equal to our direct runoff hydrograph all over our effective depth of rainfall. Okay, our D effective is our effective depth of rainfall. How? So we get our effective depth of rainfall. So we know our direct runoff hydrograph. How do we get our effective depth of rainfall? So to get our effective depth of rainfall, we need to get our volume. So we know that volume is equal to area times depth. Okay? So we have, from this point, if we make our depth subject of the formula, we are going to have that our depth is equal to our volume over area. Okay. So from the question, what do we know? We know our area, we don't know our volume. How do we get our volume? So there are several methods to get the volume, but we are going to be using the trapezoidal method. So for the trapezoidal method, our volume is given as our time into our first discharge plus our last discharge, which is Qn, plus 2 into every other discharge. Okay, so we have our volume to be equal to 1/2 times our the time concentration into the first discharge plus the plus the last discharge plus 2 times every other discharge up to the second to last discharge. Okay, so to complete our volume, we simply know these discharges, which are from 0 to 0. So this is our Q0, Q1, Q2, up to Qn. So the first thing we do is to get our time. So delta T is equal to, so our time is given in seconds for the trapezoidal method. And we are given what? 6 hours. So we have to find 6 hours in seconds. So how many seconds are in 6 hours? So we simply have it to be 60 times 60, which is in minutes. So this is 1 hour times how many hours? 6. And this is going to give us what? So this is 21,600 seconds. Okay. So we have gotten our time. So what do? Is simply we substitute the value of our time and our discharge into the equation to get our volume. So our volume is going to be equal to what? 21,006 is going to be equal to 1/2 times 21,600 into our first discharge Q0 is what? 0 plus our last discharge Qn is what? 0 plus 2 into our Q1 is what? 100. So we have these are Q1, Q2, Q3, Q4 up to Qn minus 1. So our Q1 is 100 plus our Q2 is what? Our Q3 is what? 200. Our Q4 is 150 plus our Q5 100 plus our Q6 70 plus our Q plus, okay, these are Q1, Q2, Q3, Q4, Q5, Q6. Our Q7 is what? 50. Our Q8, 85. 35 for our Q8. Our Q9, 25. Our Q10. And then our Q11, which is our Qn minus 1, is 5. Okay. So our V is simply equal to 1/2 times 21,600 into, so this plus this is simply what? 0 plus 2 into 1,000. Okay. So computing everything together. Okay, so we have half of 21,600 is what? 1/2 times 21,600 is what? Is what? 10,800 is into 0 plus 2 times 1,000, 2,000. So we have our V to be equal to, so this times this is 0, obviously. So this times this will give us what? Hence, our V is equal to 2.1 times 10 raised to power. Okay, so after getting our volume, now we remembered earlier that our volume is equal to what? Area times what? Depth. Where our depth is equal to what? Volume over area. Okay? So from this point, we can get our depth. Remember that our ordinate of unit hydrograph is giving us our direct runoff hydrograph divided by our what? Effective depth. So we have our depth to be equal to 2.16 times 10 raised to power 7 meter cube divided by, what is our area? (5.0 times 10 raised to power 8 meter square. So this takes out this. Okay, so we now know our volume. So to determine our depth is simply our volume divided by our area, which is 2.16 times 10 raised to power 7 divided by 5.0 times 10 raised to power 8. And that will give us what? 0.0432 in meters. Okay. Now, we have this in meters because this is meter cube and this meter square. Cancelling out, we have meters. But for a hydrograph, our rainfall depth is calculated in centimeters, not in meters. So we convert this to what? Centimeters. So we have 0.0432 times 100. And that is equal to what? 4.32 centimeters. Okay, so after getting our effective depth, we know that our ordinate of unit hydrograph is equal to our direct runoff hydrograph divided by what? Our effective depth. Okay, so what do? We divide each of the values of our direct runoff hydrograph by what? Our effective depth, which is 4.32. So for the first time, we are going to have what? 0 divided by 4.32. That's equal to what? 0. So for the second, we are going to have 100 divided by 4.32. And that's going to be equal to what? 22.20. Okay, so filling in these values, we have this to be what? 0. So 100 divided by 4.32, we have what? 23. Okay, so using the same approach of our direct runoff hydrograph divided by effective depth, we have been able to get the ordinate of our unit hydrograph. So this is the method to determine the ordinate of our unit hydrograph.